Hi guys, welcome to my YouTube channel Coding with Ullanasheri. So in this video I will talk about how to solve zebra puzzle using SystemVerilog constraints. In the last video we discussed about Sudoku puzzle, how we can actually resolve that through SystemVerilog constraints. So those who want, they can go and check that. So in this video I will talk about the zebra puzzle solving using SystemVerilog constraints. Okay, so compared to Sudoku, this is pretty easy. Okay, so whoever are basically starting on SystemVerilog constraints, they can actually go through the zebra puzzle first and then try to start coding the constraints. So those who don't know about zebra puzzle, they can just Google it. So here is a glance about the zebra puzzle, um, as in the wiki. So here basically there will be like few clues they will provide. Okay, and at last there will be some questions will be there that we need to resolve by from these hints. Okay, um, so yeah, so let's start coding system with low constraints and see how we can actually solve this puzzle. So here there are like 15 hints are there, and from these 15 hints um, we have to identify who drinks the water and who owns the zebra. Okay, here there is another point here, um, point is there, and which helps to create the different types of enums. Okay, so the in the interest of clarity it must be added that each of the five houses, so basically there are five houses, is painted with a different color. So color is one of the enum, and their uh, inhabitants are of different national extractions, and nationality is another constraint, and on different pets. So pets is another sorry, it's not constraint, it's enum. Drink and smoke. Okay, so these are our different enums. So this is the solution. Okay, whatever they have mentioned in the wiki. And uh, so if you look at the left hand side, right, house, color, nationality, drink, smoke, pet, so these are our variables. Okay, um, and these are all values: yellow, blue, red. From these 15 hints we need to figure out who drinks the water. So here it is already provided that the Norwegian has drink the water. Okay, and who owns the zebra is the Japanese. Okay, so how we will reach this table by using SystemVerilog constraint. That is essentially what I am going to talk in this video. So this is the template SV file where I have defined already the enums, so it is easy, and a module top is there. So now, so what essentially we need is a class, okay, of zebra puzzle, and sorry, zebra puzzle. Okay, now um, before going to the class, let's have a structure. So there is a house which contains different nationality, color, drink, and smoke and pet. Okay, so we can basically form a structure of a house which contain all these different variables. Okay, so we can have a type of then struct. Okay, and here we will be having the different, and let me name it as house. Okay, um, and let's have the different enums. Okay, and let's name it like this. Okay, that's it. Now we have the struct ready. Also we need to make it rand so that we can randomize the house. Okay, sorry. Now here we can actually have a rand house of house. How many houses are there? 5 houses. Okay, now let's add the constraints one by one, whatever they have mentioned here. Okay, let's copy paste the constraints, and we can resolve them. Okay, so let's have the constraint. Okay, so something like house underscore c we can put, and let's keep all these constraint inside this. Okay, okay, so these are five, there are five houses, so that's the reason why we have an array of house with size 5. Okay, and let's solve all these constraints. The Englishman lives in the red house. Okay, so what we can, so basically we have to iterate through the house. Okay, so for each of house of index. Okay, and let's keep it here. Now let's move here. So the Englishman lives in the red house. So how do we write that constraint? So house of index dot, there is a nationality, right? And that is for Englishman. If it's an Englishman, then we have the bidirectional constraint. I will tell you what does that mean actually. It's in the red house. So actually we can copy this house index words, because we need to use this in different places. And the color of the house is what? Red. Okay, so what does this mean? This means this is a bidirectional constraint. So if the left hand side is 1, then then that ensures that right hand side also should 1, and if the right hand side is also 1, then that ensures left hand side is also 1. Okay, so that is the bidirectional constraint, and that is required here. Okay, because that is basically what this constraint says. Englishman lives in the red house, so both has to be satisfied. Okay, now the Spaniard owns the dog. So same way, let me copy paste the index, I mean this one. Okay, now the nationality again equal to Spaniard. Okay, if that is the case, then owns the dog, so that is pet dog. Okay, now the next is coffee is drunk in the greenhouse. So what is coffee? Coffee is a drink. Okay, and if that is a coffee, then that has to be in the greenhouse. So the color of the is green. Okay, now the Ukrainian drinks the tree, so the nationality here. Okay, nationality equal to nationality equal to Ukrainian. Okay, then tea is a drink. Okay, the greenhouse is immediately to the right of the ivory house. Okay, so right in the sense index plus 1, I mean to my right. Okay, so if this is ivory house, okay, so the color is ivory, then in the index plus 1 the color should be green. Okay, now the old gold smoker owns nails. Okay, so who smoke old gold that has a pet snails. Cools are smoked in the yellow house, so cools. So cool is a smoke. Okay, in the yellow house. Okay, color. And milk is drunk in the middle house. Okay, so middle house, here the house size is 5 and the index are from 0 to 4, and the middle house here means index equal to 2. So we can have 2 house 2 dot milk drink, okay, equal to milk, right? Lives in the first house, first is index is 0, okay. Nationality, okay, clear. Now the man who smokes Chesterfields lives in the house next to the man with the fox, okay. So let's say Chesterfields stays in index 2, okay. Then then the man with the fox can be in either index 1 or index 3, right? So smokes with children, so index dot smoke, okay, equal to Chesterfield, then the fox, okay, so that pet, okay, pet equal to fox, okay, it should be the index minus 1, okay. So this is one constraint, or the same thing itself. Let me paste this here and put index plus 1, okay, fine. Now, so now there is a problem here, right? So the problem here is this, okay, I will explain it later. Now coals are smoked in the house next to the house where the horse is kept, so the similar constraint we need to apply here as well, where the smoke is cools, okay, cools, and house, and how it is horse, right? So this is horse, okay, correct, and this is cools, and this is horse, okay, right? Same constraints, only just the values are different. Now the lucky strike smoker drinks orange juice, so so the same way, smoker, right? Okay. Smoker lucky strike, okay, lucky, okay, he drinks orange juice, so orange juice, okay. The Japanese smokes parliaments, okay, nationality Japanese, okay, and he smokes parliament. Then the Norwegian lives next to the blue house, okay. So similar way how we wrote this, we can keep it here, okay, that's it. So here we need to change smoke to nationality, and this to Japanese, sorry, okay, this is not, okay, Norwegian, and then blue house, so this is color, okay, and this has to be blue, okay, fine. Now we have applied all the constraints. Now yeah, now let's instance this puzzle, okay. In the initial begin block, we can just new the puzzle, okay. Let's solve it here itself, so we can have a function, and zebra puzzle solver, something like that, okay. So that here we will, what we will do, we will call the this dot randomize, okay, and we can just print $display house, we can print, okay, percentage 0p, okay. Let's see what will happen here. Okay, module top, and here we can have puzzle of not house, zebra puzzle solver, okay. That's it. Fine, let's run this and see. Save it, run it. House dot index. So here line number 54. There is a line number 54. What is that wrong? 54. Oh shit. So there is some. This is missing. What I can say. So sorry. Okay. So these are missing. Again, copy paste. Save it. Yeah, compilation is clean. Okay, but there is an illegal array index error. So here, this is essentially what I was telling before. So here, thous is 5 dot color. Okay, so how that can happen basically, right? Let's look at one of the constraint here. Yes. So let's look at let's look at this constraint here. Okay. So here let's say the index values become 4. Now index plus 1 become 5. So that is basically an out of bound access, right? So we need to guard this with the index of less than 4. Okay. So got it right. Otherwise we will hit with these kind of outbound accesses. If index is 4, then this index plus 1 become 5, and that will be an out of bound access. So similarly, there are some other constraints also we can see here, right? Index plus 1. So we have to resolve the out of bound access here. So here, if okay, if index less than 4, okay, now yes, this is our one constraint, one condition. Okay. Similarly, wherever we have index plus 1 or index minus 1, we need to have a look. Okay. So now here also we need so basically let's say index is 0. Okay, so here index minus 1 become the negative side, so that is also an outbound access. So now let's apply the if condition here as well, but here it will be if index should be greater than 0 and index should be less than 4. In this case only we need to apply this constraint, right? But if you look at here, if index equal to 0, then this is valid, right? Index plus 1 is valid, because it can be I mean the house of 1 dot pet can be fox, so that also we can write. So else if index equal to 0, okay, then we need what? We need this constraint, right? Right? Again, else is what? Index 4. So here also we have a bit removed index 4, and if it is an index 4, then we can actually have this constraint, right? Makes sense, right? Yeah. Similarly for the other cases. What are the other cases here? Okay, so let's copy paste these things. Okay, and else if, okay, same line we can copy here as well. Okay. And for else if index equal to 0, this is the case. Okay. And sorry, and same way for index equal to 4 we can have this one, right? Okay, cool. That is one thing. And similarly for here as well, the same constraint we need to apply. Okay, so let me copy paste quickly. Okay, and okay, and for index equal to 0 we can have plus this one, and for index equal to 4 we can have this constraint. That's it. Okay, so that we have resolved here. Now again let's run this and see. Yeah, we got an answer here actually. Okay, but let's see, there's a problem here. If you look at this is an array print, right? Okay, so here you can see the norwegian is actually repeating. Okay, so that is essentially we should actually apply unique. Okay, um, to to the structure basically. Like for example, if norwegian is there, then in index 1, in index 0, then for other cases index 1 2 3 4, in that case the nationality shouldn't be norwegian, it should be other things. Okay, and again I mean if you look at here you can see some things will be repeating. Okay, so we need to avoid that actually. Okay, how do we avoid that? So here you can see I have seen water also coming twice. Okay, okay, so we need to apply the uniqueness here. So let me apply another constraint here. Okay, so here the uniqueness constraint. So what essentially we need to ensure that the values are not repeating. So let's have house of I. Okay, we should iterate through each of these things, and then we have to iterate one more time. So I will tell you the code. So this is J. Okay, now here if I not equal to J. Okay, in that case we need our unique thing. Okay, so yeah, so what essentially I mean, house of I dot nationality and house dot J dot nationality. So this is our one constraint. So let's say our I value is 0. Okay, we are iterating from J becomes 0. So at that time this condition is not satisfying. Now when J become 1, at that time we apply this constraint. Okay, so let's say for I our nationality is Englishman. Okay, for J equal to 1 it ensures that the nationality is not Englishman, and J equal to 2 3 4, in that all cases it ensures that the uniqueness is actually applied. So that house of index 0 dot nationality has Englishman always. Now when I become 1, it ensures that j equal to 0, j equal to 2, 3, 4. All these cases the nationality is some other value, not same as j equal to 1. Okay, so that is essentially what the uniqueness we are trying to achieve here. Similarly, we can do it for the other cases as well. So I will just 1, 2, 3, 4, 5. Okay, now let's do this. Okay, okay, fine. So we are now good with our constraints. Also, we need instead of this house p display, right? Let's um, try to print something like this. Okay, it's in a more readable format. So what essentially we can do is we can actually iterate through for each house. Okay, because house, there are 5 houses, right? So we can just, and now let's display house value. So here let's put index. Okay, let's put index plus 1. Let's start from house 1, and next is nationality, right? Okay, so yeah, so let's put 5, 1, 2, 3, 4, 5, and we mean something like this. Okay, and this has to be string, and here the nationality. Okay, dot name. That's it. Okay, now let's try to run this. Okay, let's run it and see the result. So I think the problem here is we need to put house of index. What is it? Okay, so house of index we are missing. House of index. Okay, dot. Okay, let's copy paste. Yeah, so it's passing, and you can just compare the result here. All same. So yellow, water cools, fox. So yeah, so water is drink by Norwegian, and the zebra is the pet here, right? So yeah, zebra is owned by Japanese. You can compare this table, it's all remain the same. Okay, yeah, so thanks guys, thanks a lot. um, this is a simple video which gives some power to the SystemVerilog constraints to solve these kind of puzzles. Okay, hope let's soon see with some other kind of interesting puzzle solving using SystemVerilog constraints. Thank you.